Well, what's really odd is that 22 minutes or 18 minutes repeating radio signal, there's not really a good theoretical explanation for that.
Some things in the universe shine with a constant, life-sustaining light. Some beam with the light of other sources. Some flash in a large explosion, never to be seen again. And some pulse. Like a ticking, or rather flashing clock, some energy sources in the universe hit us with beam after beam of photons, lighting up and darkening on a very set schedule. There are actually a fair few types of objects that do this, but scientists recently discovered one particular source of flashing light has already proven especially puzzling. It blinks about once every 22 minutes, and according to archival data, it's been doing that at least since 1988. It's called GPM, JW 183910, and scientists concerned they might have picked up a message from a distant alien civilization.
The moment we finally found that the truth is out there, I was concerned that it was aliens.
Observations show this impossible spinning object releasing a giant burst of energy 3 times an hour. And when astrophysicist Dr. Natasha Hurley-Walker discovered it, she broke out in a cold sweat.
This object was appearing and disappearing over a few hours during our observations. That was completely unexpected. It was kind of spooky for an astronomer because there's nothing known in the sky that does that. And it's really quite close to us, about 4,000 light years away. It's in our galactic backyard. It's repeating too slowly to be a pulsar, but it's too bright for a flare star. What is this?
The most obvious analog for GPM J183910 is a pulsar, a rapidly spinning magnetized neutron star. These objects release radio energy at their magnetic poles, which may not be lined up with their axis of rotation. As a result, the star's rotation can sweep the poles across the line of sight to Earth, creating the perception of a flash of radio waves each time one of the magnetic poles aligns with Earth. But the flashes of pulsars repeat quickly, with a gap between them of anywhere from around a minute down to milliseconds. And, more significantly, physics dictates the gap has to be quick. The magnetic field that powers the production of radio waves is generated through the star's rotation. If it starts rotating too slowly, then the magnetic field will drop to a point where it can no longer generate significant radio emissions. In other words, if it slows down, it goes dark, which is why we don't see any that take much more than a minute between pulses. That doesn't rule out neutron stars, though. Another option involving them is the magnetar, a neutron star with an intense magnetic field that's prone to energetic outbursts. But those outbursts also generate more energetic photons, and the researchers checked the site of GPM J183910 with an X-ray telescope and saw nothing. Plus, magnetars are thought to rotate more quickly than the 22-minute gap implies, so they're probably out as well. Another alternative is a white dwarf with an unusually strong magnetic field. These are much larger objects, and so take a lot longer than a neutron star to rotate. But we've observed thousands of them within the Milky Way and haven't seen anything like this. There's only one with periodic emissions, and it outputs far less energy than GPM J183910. Even if we expand the list of potential sources to include other objects we don't understand, we still come up short. The same team had identified another slow-repeating radio transient, Gleam X, J162759.5523504.3, a few years earlier. But it was only active for about 2 months before fading from sight, a far cry from the 35 years that GPM J183910 has been bursting. So, given that every possible explanation is terrible, where do we go from here? The good news is that these objects will be so difficult to spot that it's possible there are a lot more out there that we've overlooked. The bad news is that they're still hard to spot. The length of the burst, up to 300 seconds, and the gap between bursts means short cadence observations will likely either see something there the whole time or miss it entirely. We'd really need to have hardware stare at a single area of space for a half hour or more, and to have its staring divided up into multiple exposures, to be sure we catch it in both its on and off states. And that involves a major commitment of hardware. In the meantime, we can potentially narrow down the location of GPM J13910 to try to see if there's anything interesting in other wavelengths. However, since this is located within the galactic plane, that's going to be challenging as well. Regardless, what's notable, Dr. Hurley Walker's not quite a close encounter is not the only clue that we might not be alone in the universe. Harvard University astrophysicist Avi Loeb has made breakthroughs in research on black holes and the early universe, but he is also fascinated by the possibility of life on other planets. He had worked on a project to send laser-powered spacecraft, which use thin mirrors called light sails to explore nearby stars. But in late 2017, astronomers spotted a visitor from another star pass through our solar system. The object was named Oumuamua, a Hawaiian word approximately meaning scout, by its discoverers. Early studies of the object raised questions as it had characteristics which were difficult to attribute to natural causes. Its shape was described as a 100-meter-long cigar or pancake, and it bore little resemblance to any known comets or asteroids. Oumuamua also appeared at least 10 times more reflective than rocks usually seen within our solar system, which to some suggested the shine of polished metal. And bizarrely, as the object passed by the sun, it zoomed off at a speed faster than could be explained by the star's gravity by itself. This observation particularly then caught all scientists' attention, as it hinted at the possibility of outgassing, a phenomenon common in comets where volatile materials sublimate and create jets of gas that propel the object forward. However, no such outgassing was observed in Oumuamua's case, deepening the mystery. The majority of the scientific community favors natural explanations for Oumuamua's unusual characteristics. One leading theory suggests that Oumuamua is a fragment from a larger body that was torn apart by tidal forces during a close encounter with a star. This fragmentation could explain its elongated shape and rapid rotation. Another theory posits that Oumuamua is a comet, with outgassing that is not directly observable from Earth. This outgassing could result from the sublimation of volatile materials on the surface of Oumuamua, providing the necessary thrust to explain its acceleration. However, the absence of a visible comet-like tail or coma challenges this explanation. Additionally, some astronomers propose that Oumuamua could be a hydrogen iceberg. In this scenario, the object is composed of solid hydrogen, which sublimates and provides the acceleration force when it gets close to the sun. This theory is particularly compelling to me because it would imply the existence of a population of hydrogen icebergs in interstellar space, a phenomenon that has not been considered before. However, this idea is not without its challenges, as the survival of a hydrogen iceberg on a journey through interstellar space raises questions about its origin and the conditions required for its formation. Despite the array of natural explanations, the notion that Oumuamua might be an artificial object, an alien spaceship, has gained traction in some circles. Prominent among its proponents is Avi Loeb, who has argued that it was obvious that the object was in fact a derelict and abandoned light sail, like the kind he had been working on, made by a now extinct galactic civilization. He was so convinced by his hypothesis that he published a paper in late 2018 with co-author Shmuel Bialy, a Harvard postdoctoral fellow, stating that the object was humanity's first contact with an artifact of intelligent extraterrestrial origin. According to Loeb, a light sail is just like a sail on a boat that reflects the wind. The wind is pushing it. In the case of a light sail, it's the light reflected off its surface that gives it the kick, the push. Light is made of particles called photons. The red-tinged rock was estimated to be possibly 1,300 feet long and zooming away from the Earth and Sun at more than 16 miles per second. Avi Loeb then even published a book on January 26, 2021, which contained details that support his claim that Oumuamua was an alien light sail. According to Loeb, even if you consider a razor-thin piece of paper tumbling in the wind, the amount of area that is projected in your direction is not varying by more than a factor of 10, because the chance of seeing it edge-on is really small. It is tumbling in the wind, so it looked like this object has an extreme geometry. Despite the fact that Loeb continues to make headlines with his assertions, the copious flaws of his analysis render it thoroughly unconvincing to all but the most uncritical onlookers. After all, it's very clear that whatever the true nature of Oumuamua is, it's unlike any other object we've ever seen. There has since been a second interstellar object observed to enter into our solar system, but that one was large, volatile-rich, and comet-like, and which never approached particularly close to the Earth. There are clearly large populations of objects that originate from other stellar systems, traversing the interstellar medium. And it's eminently probable that as our observational capabilities improve, we will begin accumulating large sets of data about the types of objects that pass through our solar system, despite originating elsewhere in our galaxy. With superior data coming once the Large Synoptic Survey Telescope at the Vera Rubin Observatory coming online, we may soon have a much more definitive picture of precisely what's out there flying through the Milky Way's interstellar space. Put interstellar visitor aside, don't you know that astrophysicists were left baffled after the most mysterious star in the universe was in 2015, sparking a huge scientific debate due to its dramatic dips in its brightness. The star is officially called as KIC 8462852, but was named Tabby's star after Dr. Tabitha Boyajian, who first discovered it. Tabby's star has a combination of properties that make it entirely unique. All at once, exhibits huge drops in its flux, by up to 22%, while most planets cause 1% dips, fades slowly over timescales of decades with occasional brightening events, which no other similar stars are known to do, where the overall brightness fluctuates around the dips rather than the smooth decrease and increase seen for planets, but with no infrared emission, which all other stars with large flux dips possess. This created a huge puzzle. It couldn't be planets, because no planet is large enough to block that much light from its star. Even if you envision a planet with an enormous ringed system, like a super Saturn, those flux dips would be both periodic and exhibit a smooth pattern with a plateau. This contradicts the available data. This could have been a very young star, with planetesimals, a protoplanetary disk, and an extremely dusty environment. We've seen stars with large flux dips around them, and they've all fallen into this category. But Tabby's star is much too old to have a protoplanetary disk, many hundreds of millions of years too old. It also, most importantly, doesn't exhibit the infrared flux emission that a star with a protoplanetary disk ought to have. This is why the star was originally named the WTF, for Where's the Flux star. It could be a series of cometary events where they emit large amounts of dust being kicked up as they infall onto the inner portion of the solar system in question. This could, as was shown relatively recently, explain the short-term flux dips that have been seen. But there's another phenomenon that this proposed solution cannot account for: the long-term dimming of the star. This star isn't called Tabby's star or Boyajian's star because it was discovered by that particular scientist, only because she led the scientific investigation concerning the interesting and important new behavior. But this star has been known for over a century, and observations indicate a long-term fading, which this model cannot account for. Cometary dust gets blown off on the timescales of months. It would take a near continuous bombardment of comets to sustain a reduced flux over the timescale of over a century. Many comets in a similar orbit would be required, which is not something we know how to obtain. So, what possible explanations remained? One popular idea that was advanced was that of alien megastructures, that a civilization far ahead of humanity, technologically, was constructing an apparatus that periodically blocked a large percentage of the star's light. As the structure became more and more complete, that would increase the amount of light that was blocked. Over the past century, the fact that the light from this star had dimmed by such a significant amount could be explained by an advance in how completed the structure would be. It's a compelling, if out-of-the-box, idea. Studies claimed the strange dimming could be evidence of a Dyson sphere, a hypothetical structure which could be used by an advanced civilization to harness the energy of a star. But thanks to a myriad of follow-up observations, we know that it's wrong. The reason? An object like an alien megastructure would be completely opaque to light. It would be unable to pass through it. This is equally true of things like planets, moons, or any other solid objects you can imagine. From over 19,000 images captured in recent years, in 4 different wavelength bands, from blue light all the way to infrared light, we've learned that blue light is preferentially blocked in all dimming events, from the short-term flux dips to the long-term fading of the star. There's one thing known that can cause bluer light to be blocked, while redder light is preferentially transmitted: dust particles that go down to at least a certain minimal size. Therefore, it must be dust. Whatever is causing the flux dips, as well as whatever's causing the long-term fading, must both have a dusty origin. But this is still a bit mysterious. After all, Tabby's star is a combination of things that we wouldn't expect to find together. It's consistent with having a large amount of circumstellar dust, which normally indicates an extremely young star still in the formative stages. The star itself is brighter, hotter, and more massive than the sun. It gives off more than 4 times the amount of light our sun does. The star is old, hundreds of millions of years old, burning stably on the main sequence by all accounts. In other words, the dust we see should last only months, given the properties of the star itself. There must be some way for the star to replenish its dust. It's not because the star is young or still forming, and there are incredible constraints on the star having an unseen companion. It cannot all come from interstellar dust. Was a planet devoured? Is there something even more unusual afoot? The only way to know will be with more, and better, science on this subject. But one thing's for certain: even if alien megastructures exist somewhere, they aren't here. Last, but not least interesting, in 1977, an astronomer looking for alien life in the night sky above Ohio spotted a powerful radio signal so strong that he excitedly wrote, "Wow!" next to his data. The 72-second blast, spotted by Dr. Jerry Amon through a radio telescope, came from Sagittarius but matched no known celestial object. Dr. Amon, who had been working on a project for SETI Institute, noticed the surprisingly strong signal in a column of alphanumerical data. With a red pen, he scrawled the word "wow" in the margin and circled the sequence. Astronomers ruled out that the signal came from Earth and could find nothing in our solar system to have produced it. It is thought to have come from a region of space to the northwest of the globular galaxy cluster M55 in the constellation Sagittarius. Although Amon himself has remained skeptical, the signal has led to claims that it may have been a radio beacon or broadcast coming from far beyond our own solar system. And some claimed that the "wow" signal, which was 30 times stronger than background radiation, was a message from intelligent extraterrestrials. But in 2017, a researcher found that the signal, which has perplexed scientists for 40 years, was in fact just the trace of 2 comets as they shot past Earth. Professor Antonio Paris, an astronomer at St. Petersburg College in Florida, spent a year investigating the bizarre signal. Using celestial records, he found that 2 comets, unknown to scientists at the time, were passing by Earth on August 15, 1977, the night the "wow" signal was detected. Those comets were discovered in 2006, and last year Professor Paris suggested that a cloud of hydrogen gas in the wake of the celestial objects triggered the signal. But the scientist had to wait until 2017, when the comets flew past Earth again, as part of their synonymous 6-year orbits around the Sun, to prove his theory. In a paper published in the Journal of the Washington Academy of Sciences, he has now proven once and for all that the signals were not caused by aliens. When the comets passed by in 2017, the signal they produced was exactly the same as that seen in 1977. Speaking about the theory before its confirmation, Professor Paris admitted that he had wanted to be wrong. However, he emphasized that there's still a bit inside of him that hopes it was aliens. But Paris is not the only one who thinks so. To be more exact, there are multiple hunts for alien life currently underway. On Mars, a rover is collecting samples that may determine if life ever existed on the red planet. Probes are visiting some of our solar system's icy moons to search for signs of habitability. Astronomers are also beginning to scour the atmospheres of planets beyond our own solar system for telltale elemental cocktails that hint at alien life. And yes, we are even keeping a beady eye out for signals from any intelligent civilization that might purposefully or accidentally make contact. In our solar system, Mars is arguably the most popular destination to hunt for life at present. We know the planet was likely wet and potentially habitable billions of years ago, with seas and lakes on its surface. More recently, scientists have even found tantalizing clues that there may be liquid water on Mars still, hidden beneath the planet's southern ice cap. Currently, NASA's Perseverance rover is scooping up samples from the now dry bed of what was thought to be once a lake in a region called Jezero Crater, just to the north of the Martian equator. The goal is to collect dozens of samples and return these to Earth in the early 2030s. A mission known as Mars Sample Return, where they can be investigated in detail for signs of life. The mission is currently facing difficulties, with the return aspect struggling for funding, but if they can pull it off, there are scientific riches in store. Suzanne Schwinzer, a planetary scientist at the Open University in the UK and a member of the Mars Sample Return science team, says the presence of past life on Mars could leave a fingerprint in the interaction of its rocks and water. So, if we have the samples from Mars, we can go into miniature detail to study these processes. What's more, it's possible some of the samples could even contain fossilized microbes inside the rocks. But even if signs of life on Mars were to be detected, it would not be unequivocal proof of widespread alien life elsewhere in the universe. Mars and Earth are known to have shared material early in their history, meaning they might also have shared the genesis of life. For evidence of a true second genesis, proof that life arose for a second time independently on another world, scientists are looking to the solar system's icy moons, such as Jupiter's Europa and Saturn's Enceladus, thought to contain vast oceans beneath their frozen surfaces. If we were to find life on the icy moons, we would be sure this is a different genesis of life from Earth. Elsewhere, a NASA spacecraft called Europa Clipper is due to launch to Europa in October, following a European spacecraft, JUICE, which launched in April 2023. Set to arrive in 2030 and 2031, the two spacecraft are not likely to detect life on Europa, but they will study the extent of its ocean and set the stage for a future mission that might try to burrow beneath the ice sheet, such as an ongoing NASA proposal called Europa Lander that remains on the drawing board, or fly through plumes that might be ejected from the moon's oceans into space to look for life. But according to Brittany Schmidt, an astronomer at Cornell University in New York, actually getting a machine into the ocean of one of these worlds is a 100-year problem because of the difficulties of getting through the multi-kilometers thick ice. But getting into the ice shell and interacting with liquids is something we could do more near term. Scientists are working on instruments and technologies so we know when we get there what to do. In case you aren't quite ready to wait 100 years, then you might want to cast your gaze to other solar systems. We now know of more than 5,500 planets around other stars, known as exoplanets, and more continue to trickle in every day. With the immense power of new telescopes, most notably the James Webb Space Telescope, astronomers are now beginning to probe some of these planets in exquisite detail. In particular, they are using James Webb to see if they can work out what gases are present on some rocky exoplanets similar to Earth. The observatory was not initially designed to study exoplanets when it was first drawn up at the turn of the century, but it has since been retasked with studying these worlds, being the largest space telescope in history and thus our best machine to do so. However, notice that James Webb cannot study Earth like worlds around stars like our Sun. These planets are simply too dim against such bright stars for even James Webb to study, and will require a more advanced telescope such as NASA's Habitable Worlds Observatory, set to launch in the 2040s to investigate them. But James Webb can study planets around small stars called red dwarfs, and right now, it is flexing its capabilities with a fascinating system called TRAPPIST-1, which contains 7 Earth-sized worlds. At least 3 of the planets orbit in the star's habitable zone, where liquid water and life could exist. The first step is for astronomers to confirm if these planets have atmospheres. Research with the Webb to make this determination is currently underway, with results expected later this year or in 2025. Initial results have shown that the innermost planet likely lacks an atmosphere required for life. But if atmospheres can be found on the other TRAPPIST-1 planets, it would be a monumental discovery, because the next 20 years of our exoplanet search will depend on that result. If red dwarf planets have atmospheres, we will point every telescope on Earth at these planets to try and see something. If we can find those atmospheres, James Webb will be used to look for signs of biosignatures in atmospheres that might hint at life. Future telescopes, like the Habitable Worlds Observatory and a European proposal called LIFE, will then try to perform this same analysis for true Earth analog planets around stars like our Sun. The driving planetary class will be rocky planets in the habitable zone. And then, there's the hunt for intelligent life. Radio observations have shown that, within about 100 light-years of Earth, powerful beacons pointed in our direction don't seem to exist. So now, programs like Breakthrough Listen in the US are casting their gaze further afield. They are looking for directed radio signals coming from more distant planets in our galaxy, and are even starting to look for accidental communications leakage from planets like that which is emitted from Earth. Upcoming telescopes, most notably a vast new radio telescope set to come online in 2028 called the Square Kilometer Array, a group of thousands of radio antennas spread across 2 continents, should significantly expand this search. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.